Question on magnetic field lines now, near the south pole of a bar magnet. Part A, draw 2 arrows on the field lines to show the direction of field lines. Remember, field lines will always go from north to south. So that means we need to add 2 arrows pointing towards our south pole. It's really important that there are arrows drawn on at least 2 field lines. Which of these is attracted to the bar magnet if placed in the magnetic field? So fields affect magnetic materials. So if we look at that list, only one of those materials is actually magnetic, and that is nickel. And part C, the strength of the field changes as the distance from the south pole increases. Explain how the field lines show this. So the way that we know from field lines what the strength of the magnetic field is the closer they are together. So the fact is, as you move further away from that south pole, you can see that the field line spacing is actually changing. Okay, so that's what's happening to it. Now the question refers to it changing, but you are therefore going to have to talk about how is it changing. And because the field lines are further apart, that is telling us that the field is going to be weaker. So the further away from the pole you move, the weaker the magnetic field strength becomes. So now we want to explain why this piece of iron experiences a force towards the south pole of the bar magnet. So when you place a magnetic material in a magnetic field, what will happen is you can induce a magnetic pole in that material. So when this iron is brought towards that south pole, you will have a north pole actually being induced in that side of the iron. We know from our work on magnetism that what happens is that those opposite poles are then going to attract. So opposite poles attract, and that causes the iron to be attracted towards that south pole. So a student suggests that the iron is now a permanent magnet. Explain why the student is incorrect. Permanent means that the magnetism remains. The key thing about iron is that it is a magnetically soft material. That's why we use it in all of the things like for cores and for electromagnets, those kind of things. So it's magnetically soft. And what that means is it's very easy to magnetize and to demagnetize it. So what's going to happen is when the iron is removed from the field, it is going to lose its magnetism. So it is no longer magnetic. So it has been demagnetized when you take it out of the field, and therefore no longer magnetic, so it can't possibly be a permanent magnet.